In the world of data analytics, we often work with multiple variables. Sometimes these variables are related to each other. VIF, or variance inflation factor, is a number that tells us how much the variance of a variable is inflated because of its relationship with other variables. Imagine you have a data set with information about houses including the number of rooms, square footage, and price. You might expect that the number of rooms and the square footage are related. A house with more rooms is likely to have more square footage. This relationship between variables can cause problems when we're trying to understand the individual impact of each variable on something like house price. VIF helps us identify and quantify this problem. In essence, a high VIF for a variable suggests that it can be largely explained by the other variables in the model, making it difficult to isolate its unique effect. VIF is essential in data analysis because it helps us build better models. When we build models, we want to be sure that each variable is making a unique contribution. High VIF values indicate multicollinearity, which is a fancy way of saying that our variables are too closely related. Multicollinearity can make our models unstable and lead to inaccurate predictions. By identifying variables with high VIFs, we can address multicollinearity. We can either remove one of the highly correlated variables or combine them into a single variable. This process of checking and addressing VIF leads to more robust and reliable data analysis. Regression analysis is a statistical technique used to model the relationship between a dependent variable and one or more independent variables. VIF is particularly useful in the context of linear regression. When performing linear regression, we aim to estimate the coefficients of the independent variables that best predict the dependent variable. High VIFs can inflate the standard errors of these coefficients, making them statistically insignificant even when they might be practically significant. To calculate VIF, we essentially regress each independent variable on all the other independent variables and see how much of its variance is explained by them. A VIF of 1 indicates no multicollinearity, while higher values suggest increasing levels of multicollinearity. By monitoring VIF values, we can ensure that our regression models are reliable and give us accurate insights. Let's say we want to predict a person's blood pressure based on their age, weight, height, and daily salt intake. We might find that weight and height have high VIFs. This high VIF suggests that weight and height are highly correlated, which makes sense. Taller people tend to weigh more. Including both variables in our model might not be necessary and could lead to instability. In this case, we could consider removing either weight or height from the model. Alternatively, we could create a new variable like body mass index, which combines information from both weight and height. This example demonstrates how VIF helps us identify and address multicollinearity, leading to a more accurate and interpretable predictive model for blood pressure.